Hello guys, welcome back to my channel. This is the video number 3 in this series. We're trying to build an AI job assistant using modern generative AI tech stack. So in the previous videos we have laid down our planning documents and structured the project. In this video I will walk you through the recent steps that I have taken towards the development of this project. So the first phase is the phase A, where we've built the working skeleton of this project. Essentially the bare minimum which is required for showcasing the minimalistic functionality of the project. So after doing this phase A, we expect that the application would work end-to-end with the minimal features like the repository structures, the test cases, the endpoint checks, the dockerization and the observability. So we'll just walk through these steps one by one, and I'll just quickly walk you through this document. So what I did was I have built this phase along with Claude, and after each phase my plan is to document everything in this sort of a markdown doc, and this is what Claude summarized the whole phase A as. So just the overview. So this says that it builds the rails just to prove the entire toolchain works end-to-end on a trivial payload. The app runs, makes one OpenAI call. That call shows up as a trace in Langfuse, and the continuous integration CI is green. So that's the whole goal of this phase. Why a walking skeleton? It's just a thin slice that just touches every layer but does almost nothing. So there'll be an app, it will do one OpenAI call. The trace will be visible in the Langfuse as we will see in the later part of the video, and the continuous integration will be green. Why does this matter? Because by today's standards, the AI engineer is expected to build system around the application. It's not just some Jupyter notebook or just a proof of concept. We want to develop production ready application, and in that direction it is important that we have the nuts and bolts that hold the entire end-to-end application. So for what by that I mean, why we use these the trace calls, and why do we see if the CI is green, is because this will be used regularly throughout the next phases. We will always be required to trace the OpenAI model calls, because we want to know if the cost is increasing, if there's latency, how well the generation is, and also we'll be using Langfuse. I'm thinking we'll be using some custom model judges which will evaluate our model outputs. So this is in that direction. So that's why, although a very minimalistic application at this stage, but it is really crucial. So we'll make sure that everything is reversible and observable. the tracing, the CI, and the config all wired up at this stage, and then there'll be very trivial payload. We'll just hit an endpoint, let's say hello or something like that, just to check if this end-to-end application works. So what this whole project has is a few files. The first one, which is important, is the main.py. Here, let me just go through that. Main.py. So we have these two endpoints. We'll be checking the health of this application by calling /health, and it should result in a status OK. And there'll be another one which will be very simple OpenAI call. We'll just prompt it by asking say hello in one sentence, and we'll see the result of that. Also, and this is important, we have used the Langfuse variant of OpenAI module. So what it does is, this import allows us to trace the model calls on Langfuse. So what is Langfuse? Langfuse is just a Python package which helps us in monitoring the models and evaluating them. So by making these by linking the OpenAI calls with the Langfuse, we will be able to trace it. I'll show you where it is. Hang on. Where is it? Here. Just a second. Think. Yeah. So it looks something like that. This is the dashboard from the Langfuse, and we'll see that when we make the calls, we can see it traced here. Okay, back to the document. Yeah. So this document is just explaining what I just said. So the every call is automatically captured as a trace in Langfuse. The name of that trace would be hello-phase-a as defined in that main file. The second important file is the config, where we initialize the environment variables just once. And the important part about this config file is the content of it. I'll just quickly show you why it is important. So the way it is written, it's a pydantic settings class, and we just declare the environment file name, and this is how it is written here in the pydantic style. Now the important part about this file is that because in this phase we are not doing explicit model calls, or we don't actually need the keys from, like, let's say Arjuna job API keys or something like that. So because we won't be using these strings, even if we don't have it in at the CI stage as a phase A, let's say we don't have it, but we still want these features to be available. So we want the features to be available, but at the same time we don't want this let's say if you push it to our GitHub, we don't want the CI, which is the continuous integration fail. So what do? We define it as this class, and then we make a function, and the instance of this class is created only when this function is called, and this is how it is called. So whenever, let's say in any imports, for example, if let's say if main.py, and here if we import the config, it will not make the object from this class, right? So the keys will not be required. They're only required when the class is instantiated, and that will only happen when the get settings will be called. So that's the whole point of this file. And the LRU cache, what it does is, we don't have to instantiate every time. It just instantiate at the first call, wherever you call it, and then it stores in the cache. So that's what this document is saying as well. Okay, that's what it says. Builds settings on the first call, never at import time. The payoff: the CI can import the app with no secrets present. The third important file is the docker-compose.yml. So it has the app database. In this case, we're using Postgres, the relation database. So this is the only thing that we put down in this compose file. Now, so I asked Claude, why don't we include the Langfuse's stuff in this Docker compose file as well? So the reason for that is Langfuse is really heavy. It's got I think six services or 6 containers running, and it's upstream. So if we put all the Langfuse container information in this Docker file, it's gonna make the build very slow. So every time we want to do a CI, it's gonna build the Docker image, and it's gonna build all these other images, and it's gonna be very, very slow. So also the other reason is the Postgres app, the Langfuse is by default on 5432. So there will be a collision between these port values. So we want to separate it out. So 5433 avoids the port collision with the 5432. I'll show you how. So look, so the port value for the app Postgres, we have defined it as 5433, which in the Docker image it's going to be mapped to 5432. Now Langfuse also uses the value is so Langfuse also uses Postgres, and by default the port value is 5432. So if you want to run the Postgres for the application, there'll be a collision, right? So both will be competing for 5432, and that's why we want to map we want the Postgres to run on the host at port number 5433, right? So that's why we do this, and it resolves that issue. Now, so the workflow for the CI is written in this ci.yml file, and this is how it is written. So every pull request will initiate this CI workflow, and it's gonna build an Ubuntu image. It's gonna build all the images, then it's gonna do the linting and the indentation checks. So ruff module is used for doing these linting and the indentation error checks, and then it's gonna also run the tests which we have defined in the pytest folder. Where is it? Tests. Test folder, sorry, not pytest. Yeah, so this test is just making a FastAPI call to this application with this, which has this get call to /health, and it's going to return a 200 just to say that this application is working. Okay, so now demo time. Let's just copy this. It's gonna start this Docker containers. It's gonna list the health of the containers. So as you can see, we have the container AI job assistant v2 db1. It's a Postgres image, and this is the mapping that we discussed. So host value 5433 is mapped to this Postgres 5432 image port. Okay, and the next is the tests. We're gonna do a ruff ruff. Come on, man. Check as well. Just gonna check that, and all checks have passed. Then we are going to do the tests, the pytests, and it says one passed, one warning. So it might have returned status 200. Let's run the application, the main application, and it's going to allow us test those two endpoints. So the application startup is complete. All right, so the app is running. Right, the UV run. So we're using UV to act as an environment, and also as a package manager for us. All right, let's go to the 8000 port localhost. Actually, you can just do a call in another terminal. Let's do that. As you can see, it's returned status okay. We can also check it here, actually. Localhost 8000 /health. So if we do something like that on the browser, it means we are doing a get call. It says status okay. So we've done like 2 calls, right? First was from here and then from the browser. So we did a 2 call, and let's see on the Langfuse. Trace is on the Langfuse. Okay, let's reload it. Okay, it takes a few seconds. It must. Hang on. So the health does not call the OpenAI. So that's why there's no trace, right? If you can see here, there's no OpenAI API call. So that's why let's try hello. Okay, this time from the browser. maybe you guys can see or cannot see. I can do that again from the command line as well on the terminal. Hello. Oh, it says hello, how can I assist you today? Okay, and let's go to the Langfuse dashboard and look. Oh, that's great, fantastic. So hello phase a, the name of that trace. So one total trace is tracked, and you can see all sorts of fancy graphs over here, which at this point it's trivial and beyond the scope of this discussion. Let's get back to the next stuff that this document is talking about. Okay, so we did that. Oh, we can also do another, let's see, just for the sake of it. So we can do it from here as well, curl localhost hello, and then it responds with this the message again, how can I help you? And surely enough, we can see on the dashboard the second trace. Look, it says 2 traces tracked. Okay, this one was faster, more latencies. So for some reason the browser called. Oh, should we do this experiment again? Let's do a third call, and let's do it from the browser. Done. So remember, the first browser call had the latency of 2.24 seconds. Then it was 673 milliseconds. Right? Now let's see again. So the third one, we did it from the browser again. And look. Where is it? Yeah, look. Look. It's got 1.61 seconds. And then we're gonna try it again from the fourth time from the terminal. My prediction, it can be anything. I don't know, maybe just I'm overthinking it, but the fourth trace is the first one, the second from the terminal, the third from the browser. Where's the fourth one? Okay, I don't know, man. Alright, let's leave it for now. Okay, the payoff, the trace in the Langfuse. So open Langfuse, and then you can see that exit criteria. So now we have successfully finished the phase A, which the app runs. The /health returns a 200 as we saw earlier. Let's try it again. Health. Look, it's the status is okay, which is 200. Status 200. Try it here again. Okay, inspect. What is? Just try again. I don't know. I should show that 200 value, but anyways, that means the status is okay, 200 or okay, because in the script as well we have to see that we can we can get this status okay, and we already did, so it's working. Yes, that's it. Honest caveats. So these are the, all right, another document, the list and the piece of documents or the artifacts that's important in planning phase is the ADR, which stands for architectural decision requirements, something like that. I can show you somewhere. It was in the docs, I think. Yes. So for each design decision, like why did you choose UV as opposed to pip, we have a standard way of putting it in a document. It looks like this. Let's say, so Python UV for dependency environment context. So Python Gen AI project that needs reproducible dependencies and management builder. The system is 3.8. The one that I'm running it has 3.8. So we can't run all these fancy new modern era Gen AI stack. So it requires 3.10. So what we want, we want a different environment while running this current host machine, right? So UV does that for us. The other version was other alternative was pip, but there are reasons why we didn't use it, because UV gives everything what pip and venv together give. So venv is a virtual environment creator where we can just isolate the system and then install the dependencies there itself. But UV does everything in just one package. You just call UV init or UV run, and then it does. So it's very convenient basically. And currently, so in software engineering back practices, UV is preferred than pip, and that's why we are using it. Similarly, for why did we choose Langfuse is noted down in the ADR number 0005. We want LLM calls, inputs, outputs, token counts, cost, latency, wired from day one for the debugging purposes and for evals. Blah blah blah. Decisions, self-host, Langfuse via docker-compose, and wire its LangChain callback handler. And I wrote it a long time ago. Langsmith is excellent. There's another alternative. So these are basically the ADR is a document where we put our rationale behind some something which is critical in the development of the project. So for example, initially I had thought we'll use Claude, but then I realized I've been using OpenAI in my previous projects and Claude is new to me. So why don't we use the OpenAI again? So Claude was listed down in ADR 0004, and then the idea of OpenAI came at the very later stages. So I'm now putting it at this stage here. Now context. So ADR 004 chose Anthropic Claude, which is here. For this personal learning project, the builder, which is me, already has an OpenAI account and prefers to use OpenAI, blah blah blah. That's it. That's the only reason, because I prefer using OpenAI at this point. That's it. What else? Okay, so why do we use a different compose file for the Langfuse and for the actually Langfuse? So for Langfuse, I already had spinned up those Docker containers by just downloading the main official Langfuse repository. So I've already built that in my system before, so I do not need to rerun it again while building this project. So that's why these two are separate, and it's good. It's acting as how do I say? It's basically convenient to manage this project when we have small modules in different containers. So we're keeping Langfuse in one container, and we're keeping, sorry, not one. There are like 6 containers, and then we're keeping our main application in one container at this point of time. So that's the latest development with regards to this project that I'm trying to build. It's called AI job assistant. It helps a candidate to look for jobs online, pick the ones that or actually it automatically matches the best ones, but then it's upon the user to decide which one he or she wants to go with, and then it's gonna find the gaps in the skills sets of the applicant, and it's going to tailor the resume and create a tailored cover letter for the job application that the user has decided, and also can apply on the user's behalf, of course. Again, I have not yet thought it through, so we'll do it when the time comes. And for now, I hope you enjoyed a little bit of this walkthrough. I'm keeping it very casual and chill, as you can see. It's really the reason for this channel and this video is that I want to learn the generative AI stack as per today's standards. So if you are also somebody who wants to learn along with me and is interested in keeping up to date with the latest tech stack related to generative AI, follow along my journey. Please do subscribe and like and comment, and yeah, stay tuned for the next one. What we're gonna do in the next video, which will be about phase B, is we are going to now so we will build the application so that the user can upload the PDF resume, the resume in the PDF format. We'll pass it through the PDF extractors, and then it can be then converted into a structured output using OpenAI calls, and the user will review it, the applicant will review it, and we're going to save it to some sort of database. We're going to be using Postgres for that. So yes, all that's cool stuff in the next video, and I'll see you then. See ya, bye.